All right, 7.1 weathering. These are the notes. Again, this is from a different book, so just kind of bear with me. We're only going over the beginning of these notes. All right, so let's take a look. Weathering is what we're after. Weathering soil and mass wasting. That's what these notes are about, but we're just looking at the weathering part. All right. Mechanical weathering. Mechanical weathering occurs when physical forces break rock into smaller and smaller pieces without changing the rock's mineral composition. This is what's huge because remember, in chemical weathering, when there's a chemical change, you never end up with what you start with. There's a chemical change, the structures change. In mechanical weathering, structure stays the same. All right. Or I should say the composition stays the same in mechanical weathering, composition changes in chemical weathering. In nature, three physical processes are especially important causes of mechanical weathering or weathering: frost wedging, unloading, exfoliation, and biological activity. All right. Now, the more sides there are to a rock, the faster it will weather, the more increase in mechanical weathering. So if I just have this block, I only have 16 faces, all right? 16 faces, 16 square units, 6 sides, all right? So a cube has 6 sides, and these 6 sides are what is going to be weathered, all right? When it's broken up, you can see there are more surface areas now. There are more surface areas, and here even more surface areas. Okay, so we want to, the more surface areas that are showing, the faster it will go through weathering processes. Frost wedging. Frost wedging is the mechanical breakup of rock caused by expansion of freezing water in cracks and crevices. Sections of rock that are wedged loose may tumble into large piles called talus, which typically form at the base of steep, rocky cliffs. And we'll get a couple of pictures of talus as we go along. But here's a rock that has gone through frost wedging. The water seeps into these cracks, and you can see there's cracks all over the place. As it freezes, it pushes these pieces in different directions, and it causes them to crack off or break off. This is frost wedging. This takes years. In very cold areas, Canada and the northern United States, where it doesn't freeze and thaw many times in a winter, this takes a long time. Here in Ohio, it freezes and thaws maybe 30 times, more than that in one winter. So it goes through this process 30 times, where in, let's say, northern Canada, it's going to go through this once a year. In our climate, though, in our area, this will happen maybe 20, 30 times a year, where it freezes and thaws and freezes and thaws in one season. Unloading. Reduced pressure on igneous rock causes it to expand and allows slabs of outer rock to break off in layers in a process called exfoliation. Also, biological activity. The activity of organisms, including plants, burrowing animals, and humans, can also cause mechanical weathering. Here's some exfoliation. I kind of went over this a little bit yesterday. As this top layer heats up, it causes it to expand and it cracks loose from the underlying rock. All right. As it cracks off, this will tumble down. And if you look along the edge here, so you can see it better out here, these are what's known as the talus slopes. And we'll talk more about talus slopes. All right. But for now, you can even see some of it has gone way out here. Here's some biological activity along with the exfoliation of the igneous rocks that's causing this to break apart in a mechanical process. Again, here's more biological activity. You can see how this tree's roots are breaking into these cracks and causing this to push apart. It's pushing this rock apart. in what's known as root wedging. Chemical weathering. Chemical weathering is the transformation of rock into one or more new compounds. The identity of the substance is going to change. Chemical weathering of granite. Weathering of potassium feldspar produces clay minerals, soluble salt or potassium bicarbonate, and silica in a solution. Quartz remains unaltered. So the potassium feldspar is going to change, all right? And it changes into these different things, clay, salt, and silica. Quartz is going to stay the same. Weathering of silicate materials produces insoluble iron oxides and clay minerals. Spheroidal weathering causes the corner and edges of rocks to be more rounded. The rate of weathering, the rate of chemical weathering, there are two factors affecting this rate: the mineral composition and the physical features such as joints in that. Climate, the temperature and moisture are most crucial factors, and chemical weathering is most effective in areas of high temperature and abundant moisture, humidity. Here's some pictures of spheroidal weathering. It's pretty cool the way these rocks are rounded. Again, if you're in the northern hemisphere, what's going to happen is these cracks will fill up with ice or water, and it freezes and pushes things apart. Differential weathering, caused by variations in composition, creates unusual and spectacular rock formations and land formations. All right. So when we have differential weathering, that's when I have two different types of rocks, and I'll have to come up with some pictures and stuff of these maybe in the next section as we go over this stuff. But it creates really cool looking formations in that. So. All right, that's it for the weathering notes. Hopefully you get some good out of this and it helps.